Hi guys, it's me. I am so sorry I'm not able to be there today. I am going to kind of go through a little bit of a review and then you guys are going to take the quiz. So hopefully this is helpful. I know maybe I'm teasing you by playing Kahoot for you and you can't play. Don't sign in. Don't sign in. But I'll give you guys each a prize when I get back to school tomorrow and assume that you're all winners. So here is your bit of review. So, is the function exponential growth or decay? Ooh, so blurry. For this one, remember, if this big number here, if the base is bigger than 1, then it's exponential growth. And if it's smaller than 1, like 1/2 or something, it's exponential decay. If you're given a graph, you always read graphs from left to right, like you're reading a book. If it's going up from left to right, it's exponential growth, where if it's going down like this, it would be exponential decay. Domain. The domain for all of these exponential functions is all real numbers. It's because you're looking at the x-axis, how far this is going from left to right. And it's stretching on and on forever to the left, and it's going up and gradually to the right over here. So it includes all of the x's, all real numbers. Where the range is the y-axis, up and down, where the graph is up and down. And it goes up on and on forever, but it goes down and it gets closer and closer and closer to 2. So the y gets closer and closer to 2. The y is everything greater than 2, but nothing 2 or below. And like I said, it's getting closer and closer to 2. That is our asymptote. There's like a wall there at, a wall there at y equals 2. It's never going to go past it. And so for this one, the asymptote is at y equals 2. On the quiz, I'm going to give you these formulas. You don't have to have them memorized. Which of these formulas would you use for this word problem? If you look at it, it says it increases. So you would use exponential growth. If it decreases or it depreciates, it would be exponential decay. Now we're looking at the same word problem here. For using this formula, you put in the 1,400, that original amount of the investment here, parentheses 1 plus, and it says 25 years, that's the time. But here for the rate, you want to put the 9% as a decimal. 9% is the same as 9 over 10, which is 0.09. So you always just divide that percent. I said over 10, I'm sorry. It's 9 over 100, and so that is 0.09. All percents can be changed to decimals by dividing by 100. Same thing, which formula would you use? You see here, it's depreciating. So that means it's going down. So you would use exponential decay. Good. And so now we're just rewriting this formula for exponential decay. We're putting in our initial amount, the 18,000. We want to know the value after 10 years decreasing at the rate of 9.5%. Remember to change a percent to a decimal, divide it by 100 because that's 9.5 out of 100, which is 0.095. Take a look at this. They're giving us that initial amount, the initial population in the year 2000. They want to know the population in 2008. So over 8 years, if it's decreasing at 1%, for 8 years, what is the population? Because from 2000 to 2008 is 8 years. All right, so when you put this, after you substitute it in, and you put it in a graphing calculator, perhaps, or Desmos, you enter in, forget about this y equals, you enter all of this in just as it is, and it will tell you the answer. If you aren't using a graphing calculator to do it all at once, remember you always do the parentheses first, so subtract these two. And then take that number and you do the exponents next. So what's that number to the 8th power? And then after you get that answer, then you multiply that by 13,000. Common ratios, remember with geometric sequences, that's the number that you're multiplying it by each time. So 7 to negative 21. If you don't know what that number is, if you ever need to figure it out, you just take one of the numbers in the sequence and divide it by the previous number. So negative 21 divided by 7 is negative 3. And then you can test it out. 7 times negative 3 is negative 21. Negative 21 times negative 3 is positive 63. So for this same sequence, if we want to find the 12th term, we can use this formula. So we figured out the common ratio on the previous page. That common ratio is what we put in for R. So we put in that negative 3. So again, we're trying to find that 12th term. What do we put in for n? Well, we want to find the 12th term. We want to find A12. So we're going to put 12 in for n. And then this A1, that's always your first term in the sequence. So we'll put 7 in, the first number in our sequence. So when we put this in our calculator, a key thing about this one, you guys, again, we just want to know what this equals. If you're putting this into a graphing calculator or Desmos all at once, make sure you put the negative 3 in parentheses. If you ever have a number that has an exponent and that number, that base is negative, you always want to cup that in parentheses. So if you're not using a graphing calculator or Desmos, remember there's nothing to do inside these parentheses, but the exponent, 12 minus 1 is 11. So you want to see what is negative 3 to the 11th power. So first figure out what that answer is, which is negative 3 times negative 3 times negative 3, 11 times. And then you do the multiplying. Multiply that by 7. Okay, so this is a word problem. I want to find the value in year 8 of this sequence, of the price of whatever this is. So just like before, if you can't see what the common ratio is, just take one of the numbers, any one, 72, and divide it by the previous number, divided by 80. Or I could have taken this number and divided it by the previous number. So this is one of those recursive formulas. It's telling us the first number is 2, and then it's saying to find the next number, you take that previous number and add 2. So each time we're just adding 2. So if the first number is 2, the second number is 4. And then to find the third number, we take 4 and we add 2. So it's 6. So again, whenever you see this, this means take the previous number and add 2. Or multiply by 3, or whatever we're doing to that previous number. This is directly from Khan Academy. These recursive formulas, you always have to say, what's the first number? And then what are we doing each time? So here we would just put that negative 15. And then what are we doing each time? Well, negative 15 to negative 11. It looks like it's decreasing or getting bigger by the same amount each time. So I'm going to look and see. Negative 15 plus 4 is negative 11. Negative 11 plus 4 is negative 7. Each time we're adding 4. So the recursive formula would be, okay, the first number is negative 15. And then to find the next number, we always take the previous number and add 4. And I made a mistake on that one. On the others, I don't know why my little X isn't showing up. Oh, there it is. The last one is a geometric sequence. So this, there's a big difference between each one. So you want to see, first you can always check to see if we're adding the same number each time or subtracting the same number. But since one's positive, one's negative, one's positive, one's negative, I can see that this means we're multiplying. And so if you can't see what we are multiplying by each time, again, you just take the previous number, like this one, negative 9, and divide by, or you take any number and you divide by the previous number. So negative 9 divided by 27 is negative 1/3. Or 3 divided by negative 9 is negative 1/3. So that helps me to see that each time I'm multiplying by negative 1/3. And this one I messed up with also. It should have been 1/3. So you guys, this test, hopefully, or it's a quiz, it's not worth as many points. It's going to be in the Google Classroom. So please go to the Google Classroom and put your answers in after you're done. You can use this as a study hall. Write down all of your answers on paper in case there's any sort of glitch in the internet. If that happens, you can just start over, enter those answers in that you had gotten. And then after you're done with the quiz, you can use it as a quiet study hall. If you do not finish the quiz, like always, just submit everything that you have, and then I will let you start and pick up where you left off tomorrow. Good luck.